So hello everyone, in this session we'll be seeing all the other pending addressing mode examples. Before that, let's just work out with this sudo instruction which loads the address of label value. Okay, yes, the very first instruction we have is LDRSB. What should happen here is 8-bit of data, specifically signed 8-bit of data, should be loaded from the location pointed by R0 and placed in R1. Then R0 should be updated with 4. Okay, so here what we notice is, what is R0? 18. Let's see. From this particular location we should load a signed byte. Byte would be FE. Signed byte means what? FE. When you write binary, it will be something like this. When you sign extend it, what will happen? Remaining bits will be filled with ones. Why? Because the MSB here was 1. Okay, so what will be the result? F, 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 F and FE. Let's see that happening. Okay, we saw that result. Okay. So next what we have is LDRSH. So what should happen? Half word should be moved from here to R2. Okay, but this particular location, how do we calculate the effective address? It is R0 plus 4. R0 currently is 1C plus 4 would be nothing but location 20. So from this location we should load half word, signed half word. What is the value we see here? It is 0018. This is nothing but, because the MSB is 0, all other bits will be filled with 0. So the value that we'll see in R2 will be nothing but 18. Let's see that. There are few things you need to know about LDRSB and SH. Two condition, that is, one, offset used should be of max 8 bits and scaled register offset is not allowed. Most of the other concepts of different addressing mode can be applicable to even LDRSB and LDRSH, which are nothing but load instruction which loads signed bytes and signed half word into desired registers. Okay, now we will check about PC relative addressing mode. Okay, what is PC relative addressing mode? Here we are using PC itself or the program counter itself as the base register. Is there any difference between these two instructions? No, both are exactly same, because if you notice here, R15 register is nothing but your program counter. Okay, so I just wrote both so that you know both works in the same way. Now let's see what exactly is happening here. So as per our instruction, what should happen is PC content should be added with an offset. Okay, but what we should know is, when you use PC or R15 here, what internally happens is add current instruction address plus 8. Okay, so what is this? If you check in the assembly window, okay, you can see that the current instruction, that is R9 comma PC comma has 0x004. This particular instruction has address C as shown here, and you can see same value in register R15 also. Okay, because this particular register will be storing address of the instruction which is to be executed next, and that is this instruction. Okay, so same value as shown here will be stored here also. Or if you see internally, this particular current instruction address, what it should be? It should be nothing but C. So this C should be added with 8. To that we add offset. What is offset? It is 4. That is nothing but 8 plus 4 is 12, and C is nothing but 12 only. So 12 plus 12 is nothing but 24. So if you check what exact value is there in the location 24, same data should be copied to register R9. So let's see that happening. Okay, so this is nothing but 24 in decimal. In hexadecimal it is nothing but 18. So this particular data should now be placed in ARM9. Let's see that happening. Yes, A, B, C, D, E, F, F, E. It is placed in the opposite order due to Little Indian concept. Okay, now let's see the next case. What happens there? So here again we have the instruction, just we have replaced PC with R15. This internally gets converted to PC only. So there is no difference in both of this instruction. So let's see what's happening here. So as we can expect here, we have to add current instruction address plus 8. If you notice, the current instruction, this current instruction is this one. Okay, this is already executed, as you can see green here. This is the current instruction to be executed, because of which the address here will be 10 pointing at this particular location. Here you will get 10, it is 10 in hexadecimal, that is 0x10 plus 8. Okay, that is your PC internal value. Okay, this should be added with offset, which is 4, that is 12 in hexadecimal is C plus 0x10, which is nothing but 1C. So from one location 1C, whatever data is there, we are loading it to R9. Let's see that 0x1C. Okay, so the value 1 2 3 4 5 6 7 8 should now be placed in R9. Let's see if that happens. Yes. Okay, so what you should know here is, in case of PC relative addressing, the current instruction address is added with plus 8. To that the offset content is added. Okay, and whatever result you get from that, they are loading the content to the desired register. It need not be arg9 here, you can use any register here. Okay, and an example or use case of PC relative addressing would be in case of branch instructions. Okay, internally they will be performing PC relative addressing only in order to jump to some label. Okay.